and welcome to a new open class number 145. I hope everything is fine, sound is fine, video is fine. So let me know please here in the chat so that I can see that everything is fine and I can continue with the class normally. Quiet audio is saying Mike, we can hear you. I sound strange. In what sense? Hello, hello. Hello there. Okay, here from my side, everything looks correct. So maybe I can try. Some people, yeah, Timothy. Okay, let's try like this. I'm going to try to not move too much my face, not turn around, and so that the sound keeps at good quality. Okay, but yeah, it's normal that when I turn like this, maybe the sound gets a little bit quiet. But yeah, we should be able to do it like this. All right, so let me right now already switch to my computer screen, and we are going to start. So today we are going to have a quite a bit special open class. So there we go. So here I am already in the platform, and today let me come here to the live streaming so that I can see the chat in case that you say anything. All right. Yeah, so today we're going to have a special, let's call it like this, open class, because we are not going to be talking about a specific subject like we usually do, but we are going to do a bit of an overview on this new ROS2 distribution, which is ROS2 Humble that came 1 month ago, more or less. And we are going to be checking some of the updates that this release brings, some of the new features, with some demonstrations to understand it better. So yeah, let's not lose any more time and let's get started with it. So as always, I don't know if you are familiar with open classes. I am seeing some new names here, at least they are not familiar. But for the open class, the first thing that you need to do is to click on this light blue button, which says fork, and open the class rosject. So I am going to do this myself. And this is going to take you to the rosject page. So it's going to automatically create a copy in your account of this rosject. And it's going to also, as you can see, open the rosject here. Yeah, it's going to automatically take you to the rosject page, where we are going to be working and running and testing the different demos that we have. Thank you, Arnoud. Yeah. So I sometimes talk a little bit of Spanglish, but yeah, hopefully it's going to get better, the accent with the time. All right, yeah, so here at the right side, as you can see, you have the streaming panel, which with the chat, the live stream, so that you don't lose anything. And then here you have the main rosject screen, which is where we are going to be working. So automatically here, you should have also opened the notebook. This is a Jupyter notebook, which contains all the instructions, everything that we are going to be doing today, we are going to be talking and discussing today. Everything is included here in the notebook, all right? So you can check this anytime you want. And yeah, so let me know, please, now if you have been able to open the rosject properly, if you are here in the same page as I am. Error, what is this error? DIN. It looks like a gazebo error. Okay, so let's then get started so that we are all on the same page. Then the first thing we are going to do here is to start a ROS2 simulation, all right? So we are not going to be using this simulation for all the demos, but we are going to use it for some of them. So we can already start it here and leave it running. So it's not, we are going to have it there. Then here, in order to start the simulation, you have here this section, how to launch the simulation. Then first of all, we are going to run here a source command. So what I suggest you do is to copy directly the commands here from the notebook, all right? And then you can paste them here into the shell like this. So we are going to source here our simulation workspace, and then we are going to run this command, which basically it's going to execute a bash script, an sh script. Then this is going to start executing some commands and running some processes. You might get some errors related to gazebo, but you can ignore them. I'm going to be paying attention here to the messages we are getting. So we might get some errors related to the models and all that. But those errors, generally, you can just ignore them, and they are not going to affect the simulation. So let's see. Yeah, so here it's starting gazebo. And after some seconds, when everything loads properly, we should have the gazebo window automatically opened. So we are going to see here if my gazebo, here we go. So my gazebo window has been opened. Here I'm getting some model-related errors, which I suppose that are the ones that Dean was getting. Okay. Yeah, and this is something that sometimes happens, which is that the simulation spawns without the robot. Okay, these are some timeouts that happen when spawning the robot, okay? In case that you have this, so in theory, if everything goes okay, we should have a simulation like this one with the robot here in the center of this O, okay? But in case that you don't have it, don't worry, okay? All you have to do is just close the process and relaunch it, okay? And this is going to probably solve all these kind of spawning issues. Yeah, so the client sometimes does some strange things. I think now my client is stuck here because he should have loaded. Let me relaunch it one third time. There we go. Okay, yeah. So this is what you should get when it's launched properly, okay? So you are going to get this Robotics. This is a Robotics NP400 robot, by the way. And we have it here in an empty world with a drawing here in the plane, in the ground plane, which says Robotics. Okay, but yeah, so this is the world that should load once you have it working properly with the robot here in the center of the letter O. All right. Yeah. Have you been able to load the simulation? Yes, no. Yes, says Sudarshan. All right. Okay, so yeah, so let's you got it right. Takes too long. Try again. Yes, yes. Takes too long. Try again. Yeah, if it takes too long to load, just stop the process and relaunch it. Arnold. Okay, if you see that the gazebo client or window gets stuck without showing anything, just stop the command and run it again. Okay, sometimes it gets stuck, the gazebo client. All right, so now it works. Perfect then. Yeah, so as I was saying in the introduction of the class, today we are going to be doing a kind of special open class. Yeah, so usually in these open classes we address one specific subject related to robotics. It can be ROS2, ROS, but we usually address one specific topic and then we do some demonstration and we teach a little bit about that topic. So today it's going to be a little bit different because we are going to go a little bit over the place. Yeah. So for being able to follow what we are going to be doing, you should have a beginner knowledge of ROS2. Okay, know a little bit about the common stuff, like we are going to be creating launch files, we are going to be creating some ROS2 nodes, we are going to be compiling packages, etc. So yeah, it would be good that you have some foundation on ROS2. Okay, so for this I have left you here a couple of links where you can get this knowledge in our ROS2 basics courses. We have two of them, one for Python and one for C++. Yeah, depending on which is your preferred language. And yeah, so if you click here, this is going to take you to our academy, to the course, and you can have a look. And here you are going to learn all the basic stuff related to ROS2. All right. Then, yeah, so once we have said this, we are going to start with the class. So ROS2 Humble, which is called Humble Hawksbill, it's the latest release of ROS2, and it was released in May 2022, so 1 month ago, more or less. And one important thing to note is that it is a long-term support, which is usually known as LTS release. Okay, long-term support release are releases that are going to be supported for a long time, as the term itself says. Yeah. So in this case, for ROS2 Humble, it is expected to be supported until May 2027. So in case that you are thinking about starting with ROS2 but you don't know which distribution to choose, etc., this is a good moment to do it because usually you would like to start with a long-term support release. All right. Then. So also we are going to be checking today some of the updates, some of the new features. But if you want to have a look at the complete documentation of everything that this new release ROS2 Humble brings, you can have a look here at the official documentation. Okay? So here you are going to find everything related to this new ROS2 release. All right? So here we are going to be using, we are going to be covering some of these parts. We are going to be checking also some demonstrations from here, etc. Some others are more customized, but yeah, here you are going to find all the detailed and extended information of this new ROS2 release. All right. Then, yeah, one thing to note is that this ROS2 release, ROS2 Humble, is the first one which comes for Ubuntu 22. All right. So this rosject that you are running right now, of course, it's based on ROS2 Humble, and it's based also in Ubuntu 22. All right? So this is an important thing to note, but of course, it's not the only OS system or platform that where it is supported. The other big platform is Windows 10. There are others also which are of a lower tier, like Real 8, Ubuntu 20, Mac, etc. So whenever you want to install a ROS distribution in a platform, in an operating system, usually you want to go for the tier 1 platforms. Yeah, these ones have been tested and they are going to work perfectly. Okay, for lower tiers, you are very likely going to encounter or find some bugs in the process. Yeah, so it's not recommended for not ROS experts. All right? Okay. Then, yeah, so we have already introduced a little bit this new ROS2 distribution. So let's start with the new features. Yeah, let's start reviewing some of the new features that this new distribution brings. So for this, we are going to start creating a new ROS2 package, which we are going to name like this, Humble Tests. So let's open a new shell, a new terminal. You can do so very easily here from the terminal window and clicking on the Add icon here, Add button. This is going to open a new blank shell. Okay? Then a very good question from Arnold. Arnold is saying, in ROS2 workspace SRC, the answer is yes. So we are going to create this new package in our ROS2 workspace and inside the SRC folder. So we need to, first of all, go there. Okay, you can go there with a cd command, cd ROS2 workspace SRC. Now, once you are here, you are going to see that there are once you are here in this path, home user ROS2 workspace SRC, you are going to see that there are some other packages here, okay, which I have placed intentionally here. We are going to be using some of these for different demonstrations, okay? But here is where we are going to execute our command and create our new package, all right? So let me run this command. And this is going to create a new package, as you can see here, Humble Tests, under the ROS2 workspace, SRC folder, okay? Also, here we are working with the shell, with the terminal. This is a regular Linux terminal, but in case that you want to have access to all the files, folders, etc., with a graphical tool, you can open here the code editor. Yeah, here at the bottom bar, you have this second icon, which is the code editor. If you click here, this is going to open an integrated development environment, which is going to give you access in a graphical way to all the workspaces and folders and files, packages that we are creating, okay? For instance, here you can see the new package that we have created, Humble Tests, okay? All right, then next thing we are going to do is to create a launch folder inside our package, okay? So we are going to create here a new folder, which we are going to name Launch. And inside this launch folder, we are going to create a new, we are going to create a new launch file, which we are going to name like this, test.launch.xml. Okay, so let me create myself here. So you can create new folders by right-clicking in the package and select a new folder. For instance, this is how I did it. You can create it also from the shell if you want with mkdir, whatever you prefer to do. And same goes with files. So you can right-click here in the folder where you want to create your file, right-click and then select a new file, and you name your new file. In my case, it's test.launch.xml. Okay, and then inside my launch file, I'm going to paste the code which I have here in the notebook. Okay? So this is an XML launch file, okay? An XML formatted launch file. You have also the same with Python, okay? Let's actually create also this second launch file very quickly. So let me create another file, test.launch.py. So as you might already know, if you have some experience with ROS2, in ROS2 there are different ways of creating launch files. The most common one, let's say, at least the initial one, was through Python scripts, like this one. But then later, they have added support for XML launch files, also YALM launch files, okay? So basically, these two launch files are doing exactly the same, but they are in different formats, okay? And both of them work for ROS2. All right, so once we have our two launch files, what we are going to do is to install these two new launch files and compile our package in order to do so. So for this, we are going to open here the cmakelists.txt file of our Humble Tests package. Yeah, we open the CMake lists, and then we are going to add this piece of code here. Yeah, this install command. You can add it, for instance, here on the bottom of the file. Yeah, this install command, which basically is going to install everything that I have inside the launch folder. Yeah, which in this case it's my 2 launch files. So yeah, once we have updated our CMake list.txt file, we can already compile. Yeah, then where should we compile? So in order to compile, we don't compile here in the src folder, okay? We don't compile here. We have to compile in the root of the workspace, here. Yeah, not in the src folder, but in the ROS2 workspace folder, which is the root of the workspace. Yeah, then, yeah, let's compile this. Qualcomm build. Yeah, here we are getting some warnings. Okay, so yeah, there is this error with the, I think it's the custom interfaces package. So okay, I think I might know what this could be. Let me have a very quick look here. Yeah. So let's do one thing. Let's comment out this. Oops, sorry. Yeah, so we don't care yet about this package because we are going to work with it later. But if you want to avoid getting that message, this should make it. Okay, so we should be able to comment this line. Let me see. Let me try it and see if the error goes away. Okay, yeah. So let's take all these out then, and later, well, you can just ignore this message if you want. Okay, I'm going to just comment out all this, and later we will come back to this on the. Yeah, so let me take out all these. Okay. And now, let's stop this. All right. Yeah, these warnings, by the way, you can ignore them, okay? These messages, they are just stating that the setup tools version is a different one, but you can just ignore these warning messages. They are not going to affect in anything. Yeah, so now it's compiling everything right, and so on. And now what we are going to do is to test our launch files, okay? So let me already copy my command here for when this finishes compiling. All right. Always important to source also after we compile. And then we can run our launch files. And as you can see, we are going to get an output like this one. Yeah, you have it also here. We are getting printed here with an echo a number 1, okay? So, and what's the thing about this? Okay, so why we are doing and running these launch files anyways? So here the interesting thing is that, let me show, for instance, this one, which is maybe more clear. So as you can see, we are setting here an environment variable, which is foo. And we are giving it a value of 1, okay? Then down here we have a group tag, and inside this group tag, we are changing the value of this foo variable to 2, okay? And then at the end, we are printing the value of the foo variable. And the result we are getting is 1, not 2. Why is this? Well, this is because we are using this group tag, okay? So in ROS2 Humble, this is something that wasn't happening in previous versions of ROS2. Yes, so this is why we are doing it here. So in ROS2 Humble, whatever you do with environment variables inside a group tag, a group action, is going to be kept inside the scope of this group action. Okay? If that makes sense. So that's why, even though we are changing here the value, this is not affecting the foo variable where I am printing it. So if I was printing the value of the variable inside the group action, then I would get a 2. But since I am printing it outside the group action, then I am getting a 1. Yeah? Same applies for the Python version. So we are setting the environment variable foo to 1. Then I have a group action, as you can see here, where I am changing its value to 2, but this is not going to alter the echo command. Okay? So this is an interesting new feature that that brings ROS2 Humble. Then let's have a look at the launch PyTest. Okay, another new feature. This launch PyTest is a package that has been added and that can be used to perform different tests in ROS2. Okay, so in order to make use of this, we are going to have to install this package. So you have these commands here. Let's start by running a sudo apt update, and then we are going to run a sudo apt install. Yeah, we are going to install the package ROS Humble launch PyTest. Okay? So let's run it here. This is going to install the PyTest package, which is a new package introduced in ROS2 Humble. And that, as I was saying, it can be used to perform different tests in ROS2. So, yeah, here you have some of the new features that this launch PyTest package brings, and also down here you have a link to the official documentation. Okay, so in case, I'm not going to go into details, but in case that you want to learn more about it, how to use it, different examples, etc., you have the documentation, the link to the original repo here in the notebook as well. All right, then let's go back here and let's create our own test. So inside our Humble test package, we are going to create a new folder named scripts. Okay, so we can close already these two launch files, and we are going to come back here to our Humble test package, and we are going to create a new folder, which we are going to name scripts. All right, then inside this scripts folder, we are going to create here a new Python script, which we are going to name simpletest.py. New file, simpletest.py. And finally, inside the file, of course, which is empty, we are going to paste the code that we have here in the notebook. So let's copy here the code and paste it here into our script. Okay? Now, we can directly run our tests with the following command. So we don't need to compile, because we are going to be executing the script with Python directly, as you can see from here. Okay? So we can run this command here. Let me copy it from the notebook and paste it here. Python I am missing here, yeah, the pi. There we go. Yeah, so here, I don't know you have it like this also, but make sure that you have the file name properly executed, okay? And by the way, there is a typo here, because the script is not named test.py, right? It's named simple test.py. So if you actually want to run your script, you can rename your file here, or you can just change the name of the script here by simpletest.py. Okay, so we are going to be running directly here with the pytest flag our Python script that we have just created. And this is going to automatically detect and run the tests of my script, and in this case the test has passed. I had one test and it has passed. So 100% of the tests have passed. Okay? Then I'm not going to go into details, but you can have a look. This is a very, very, very simple example. As you can see, we have just a function here where we are echoing, we are printing a hello world. Okay? As simple as that. Then here we have a fixture, okay, where we define what we are going to be running. So we are going to be running our hello world proc function, which we define it up here, and then we have a call here to the ready to test. Okay? And then we have to define here a launch. Yeah, this don't like this. This is defined like this in the package. If you check into the documentation, you are going to see that you always have to define a launch, a mark.launch, a fixture, okay? And in your launch, you are going to attach it to a fixture that you have defined. In this case, we are attaching it to our launch description fixture, which is the one that we have defined here. Yeah, which indicates what we are going to be launching in our test. Okay, then we have a function here where we are going to be validating the output. So we check that the output of our echo command is hello world. Yeah. So this is a simple test, but if you have a look, as I was saying, I'm not going to go into this, because I just want to introduce some ideas of new features. But in case that you want to learn more about how this script is generated, how it works, how to create more complex and more interesting examples and tests, you can have a look here at the documentation. Yeah, you have the link to the official repository right here in the notebook. All right. Yeah. So let's go with the next. So now in ROS2 Humble, another new feature is that we can directly pass ROS arguments to node actions without having to use the ROS args flag. Yeah, this is something very interesting. It's not a huge change, but it's going to save a lot of time. Okay. So let's build our demonstration, our example, and then later we are going to pay attention specifically to what is the change. Okay? So now we are going to work with the parameter test package. Okay? As you can see here, I'm going to already close this, and now we are going to work with the parameter test package. So here it says, inside the parameter test package, create a new folder named launch. Inside this folder, add the following two new launch files. Yeah? So, in this case, we are going to come here to the parameter test package. Then, what is telling us, the notebook, is to create a new folder named launch inside this package. So, let's do it. Let's create a new folder named launch inside the parameter tests package. I don't know what I did. Okay, there we go. And now inside the launch folder, we are going to create a couple of new launch files. First one is this one. So let me create a new file here. And inside this first one, I'm going to paste the code that I have here in the notebook. Okay? Very simple, just a few lines. Okay? And we can do the same if you want, as we did before with the Python version. Yeah? So let's create also the Python version. Here, new file, test parameters.launch.py. Okay. Now, again, we are going to have to install this new launch folder, just as we did before, right? So we need to install the contents of the launch folder, so our launch files, in the system. So we are going to do this by adding this line here. In this case, there is a difference, okay, because our Humble tests package is a CMake package. Therefore, it contains a CMake list file, which is the one that we updated. In this case, the parameter test package, it is not a CMake package, but it is a Python package. Therefore, it doesn't have a CMake list. So in this case, the equivalent of the CMake lists in a Python package is the setup.py. All right? Then, if we want to install the launch folder with its contents, we are going to need to add to our setup.py this line here. Yeah? The imports, we already have them, so we are going to have to add this line here. So you can copy it directly from the notebook, like this. And then you are going to have to paste it here, inside the data files, okay? Then basically this, what it's going to do is to install everything that you have inside the launch folder, okay? So, yeah, so now, again, we are ready to build. So let's come here and let's Qualcomm build our workspace. And we are getting the warnings, which we can just ignore. Okay, so yeah, now before running our launch files, let's have a very quick look at what they are doing, right? We have 1 and 2 here, yeah? So basically, what we are doing here, as you can see, is that we are using directly this ROS-args tag. Okay, so inside our launch file, we have our node tag where we define the package, the executable that we want to run, and okay, it is back. No worries. I don't know what happened there. Yeah, so we have the package tag where we define the package, the executable, the exec tag where we define the executable that we want to run, and then here we are using this ROS-args tag. And then inside the ROS-args tag, we are specifying the params file flag and a path here to a parameters file, which is this parambelnode.yalm, which is inside the config folder. Yeah, if you open here the config folder, you are going to find this YALM file, which basically is setting this parameter to 0.2. It's setting a velocity parameter to 0.2. Okay? This parameter, so in case that you want to check also this executable and everything, you are going to find the source code here. Yeah? This velocity parameter is just, this is a node, custom node, and this velocity parameter is a parameter that can be used to control the velocity of the robot. Yeah, of this robot that we have launched at the beginning of the class. Yeah. So then basically what I am doing here in my launch file is to load this YALM file, which is setting the velocity parameter to 0.2. Okay. So I am loading this parameter, and then I am loading this parameter into this node. So whenever I run this launch file, my robot should start moving at a velocity of 0.2 meters per second, right? Then what is the interesting thing here? The interesting thing here is that we can use ROS arcs directly, okay? In previous versions of ROS2, this was not possible. Yeah, you have the explanation exactly here. So in previous versions of ROS2, you would use the arcs tag, and then inside specify the ROS arcs flag, and then specify the params file flag. Yeah? So as you can see, it's a little bit more cumbersome. So because you have to specify this ROS arcs flag. You weren't able to use ROS arcs directly here as an argument, right? So now this is possible, which it's pretty convenient for creating launch files, okay? And exactly the same here. Yeah, so in the Python format, we have exactly the same. In this case, instead of ROS arcs, it's named the parameter to the parameter to use is ROS arguments. Okay. Small change, but very interesting and very useful to save time and to make things clearer and simpler. So then let's try it. Let's just run it and confirm that everything works. So now we can run our launch file. You can run any of the two. It doesn't matter. Both are the same. So let me come here and run my launch file, and then if everything works okay, the robot should start moving here at 0.2 meters per second. Okay, as you can see, the robot there, it's moving forward. All right. So now you can stop it also, for instance, by setting the parameter back to 0. ROS2 param set. Well, let me get a list first, because I don't remember the name of the node. Let me move this. It's where are you? Grep. Oh, right. So ROS2 param set, param bell node, velocity, and then we can set this to 0, which is going to stop the robot. Okay. All right. So another interesting new feature that has been added in ROS2 Humble. Let's continue. So another very interesting thing that has been introduced in ROS2 Humble is the front-end support for composable nodes. Okay, if you don't know what composable nodes are, it's okay. Okay, composable nodes is a new way and the recommended way of creating nodes in ROS2. Okay, I'm not going to explain it here because it would be too much. Maybe we can put this into another open class. But yeah, basically you can now load components directly from launch files in XML format. Okay, so in this case we are going to be working with the my components package. Okay, so this is another of the packages that I had placed already here. And if you open this my components package, you can have a look at the nodes here if you want. They are written in C++. And there is also a launch file here, which is combinedcomponents.launch.py. If you open it, you can see that here what we are doing is to start a container. Yeah, you are starting here a component container, and then you are loading components into this container. We are loading two components in this case. Yeah, we are loading the move robot component and the ODOM subscriber component. Okay, these are two components, two nodes that do different things. The move robot moves the robot, and the ODOM subscriber subscribes to the odometry topic. Yeah, you have the codes here. I'm not going to analyze it because it's to match. You can have a look at your own if you want. Then what has been added in ROS2 Humble is support for doing this also in launch files with XML format. Okay, so what we are going to do is to create a launch file in XML format, which is going to do basically this. Okay, so let's create inside the launch folder a new launch file, which we are going to name components.launch.xml. Okay, I'm not writing anything here. Components.launch.xml. And then let's copy and paste this code here. So now in this launch file, what we are doing is basically the same. So let me close all this. Yeah. So as you can see, we are starting a container node first of all. Yeah. And then I am loading my components. Okay, so I am loading the move robot component and I am loading the ODOM subscriber component. There is a question from Arnoud. Did you not modify the CMake list txt of this package? No, in this case it's not necessary because we already had the launch folder. Yeah, so all we have done is just to add a new file into this folder. But since the package already has a launch folder, then the CMake list is already installing this. So we don't need to add it, okay? In the other cases, we were creating from zero the launch folder, so we had to add also this. So no, here in the My Components package, it's not necessary to do this, okay? So yeah, very interesting, this front-end support for composable nodes. Yeah, so we can now start node containers and load components into them from front-end launch files. Okay? So for this, we can very quickly compile. We don't need to modify anything else, only create this new launch file. So we can directly compile, source, and then we can run our launch file like this. Actually, this is wrong in my case. The name of the launch file is, yeah. So as you can see here, there is a typo also in the command. Yeah, because the launch file, this is going to fail. If I run it, this is going to fail. See? Why? Because the name of the launch file is not correct. Okay. So the correct name that I have given to my launch file is components.launch.xml. Okay, this is correct. So basically this is going to, what this launch file is going to do is going to start a container, and then it's going to load this component, move robot, which is going to start moving the robot around, the robot that we have here in the simulation. And then after that, it's going to load a second component, which is this ODOM subscriber, which should start printing odometry. Okay? I don't remember what is going to print. Yeah, this is going to print here odometry messages. It's going to print the position in the X coordinate. Okay, as you can see here. So let's run this and verify that it works. So now the robot should start moving. There it goes. It's moving in circles. And then also I am getting the X position of the robot here. Okay? This is the current X position of the robot. All right. So let's stop our program. We have checked that it works. Yeah, so if you want, you can use this command here inside the nodes in order to stop the robot, because otherwise it's going to keep moving here forever. So you can just run this command here to publish a zero velocity message, and that is going to stop your robot. All right? Okay, so let's keep advancing. There are many, many things, okay? So, yeah, another very interesting feature that has been added in ROS2 Humble is support for using CRL, Certificate Revocation Lists. Okay, this is a subject related to ROS2 security. Okay, but it's pretty interesting, and I think it's worth that we try this demo here. So, yeah, so these certificate revocation lists basically are certificates that you can attach to certain nodes, and then other nodes, if they don't have the same certificate, they are not going to be able to communicate with this node. Okay, a very interesting ROS2 security feature. So we are going to start by creating a new folder, okay, for this demo. Then let's copy the command directly from here. mkdir, we are going to create this new sros2 demo folder. So let's run this command, and this is going to create, if you have a look here, this is going to create this new empty folder right now. Okay, here sros2 underscore demo. Okay, then let's get inside this new folder with a cd command, and then we are going to run the following command. ROS2 security create keystore demo keystore. Okay, this command is going to generate keys and certificates, which we are going to attach later to certain nodes. Okay, but first we need to create these keys and certificates. So let's run this command. Not this one, this one. ROS2 security create keystore demo keystore. There we go. Okay, and now we are going to run these commands below, where we are going to attach, let's say, enclave the keys to these nodes, to a talker node and to a listener node. These two nodes are demo nodes that are provided by default by ROS2. Okay, this is a talker demo node and this is a listener demo node. Okay, so we are going to provide the keys to these nodes. So let's run these two commands. There we go. Okay, so now, in order to test this setup, we have to set some environment variables. Yeah. First, we are going to set this ROS security keystore. Okay. We set this environment variable and we indicate here the path to the demo keystore. Yeah. Then we set the ROS security enable to true. Okay, ROS security enable to true. So we are enabling the ROS security system. And then also the ROS security strategy, we set it to enforce. Okay, I'm not going to enter into details of all this because also it would be too much. So let's just set here the demonstration, and then if you are more interested, maybe we could also create another open class on this because it's very interesting. Okay, so now what we are going to do is to run this command. Yeah, ROS2 run demo node cpp talker. Yeah, so this is the package and this is the node that we are going to be running, which I already told you it's provided by default by the ROS2 installation. And then we are providing here the enclave, talker, listener, talker, yeah, that we have set previously here. All right? Then if I run this node like this, yeah, found security directory, as you can see here, it has found a security directory, and then it starts publishing. So now I can do the same for the listener. Okay? So, in order to be able to do this, however, yeah, so this is not working, okay? So in order to be able to run this, I have to still set the environment variables, right? If not, this is not going to work, okay? So let me set my environment variables, and now I'm going to run my listener node. There you go, now security directory found, and now the connection is made between the publisher and the subscriber. Yeah? And now this connection between the two nodes is encrypted. Okay? It is using authentication and encryption at this point. Yeah? So the messages that are being sent by the publisher and read by the subscriber are encrypted. Okay? Now, what does this to do with CRLs anyways, with the certificates anyways? Nothing, okay? So at this point, we were setting a little bit a ROS2 security system. So now we are going to do the specific demo about certificate revocation lists, all right? So for this, we need to create the certificate. So you can already stop the nodes here if you want, both the listener and the publisher. Let's go inside the demo key store folder, okay? And then here we are going to create a certificate. Yeah? So for this, we are going to run this wall command here. Okay? Then let's copy the command, all this command. Here basically we are printing into this CRL openssl.conf. We are writing all this inside this file, okay? So let's copy all this and run it here. See, so now this has created this new conf file. Yeah? So now that we have created the certificate, we need to still run some extra commands. So we are writing here. Yeah, so let's. All this is very technical, very specific to security systems. So yeah, I'm not going to go over everything, all the details of all these commands, because that would be too much, okay? But basically here we have generated the CRL, yeah, the certificate revocation list. Then we are going to run this OpenSSL command, yeah? And now give me 1 second. All right. Okay, so yeah, so what are we doing here? Yeah, so basically, if you check here, what we are doing is to set a revoke. Yeah, so we are revoking here the listener. Yeah, with this command, what we are doing is to revoke the connection from the listener. Okay? And we are going to link this now to the, we are going to link this to the talker enclave. Okay, so that it knows about it. Yeah, this is a linking command. It's going to create a soft link. So, yeah. Okay, now, finally, let's go into that. So now we are going to run one more time here our Total node, okay? Let's run one more time our Total node with the latest modifications. It's going to start publishing, but now, if I run again my listener, let's do it again. So you saw that a moment ago this was working. So now, if I run this, I'm not getting here access. Yeah, so I am not receiving the messages. See? Now? Why? Because I have revoked my access from the listener to my talker. Okay? How do you give the listener again access? Yeah, in order to give it access again, you can just remove the revoke, for instance, or allow access from the listener into the CRL document. Yeah, you can do it with an OpenSSL command. Yeah, I don't know exactly the command right now, but yeah. Yeah, I think this would be a very interesting topic, maybe for an open class. Yeah, to talk a little bit about ROS2 security. So and go more into details, a little bit on this kind of stuff, which is interesting. It's complex, but it's interesting. So yeah, I think this might be the subject for one of the following open classes. And yeah, I'm going to have to leave it here because there are still more things to review here. Some things, interesting things related to the ROS2 command line tools, ROS2 CLA. Interesting things here also from RVs. With lifecycle nodes, which have support now for Python, for RCLPy. But yeah, so time is already gone. So I'm going to leave all the rest for you, okay? So you are perfectly able to follow this. You have all the instructions here, as you can see, all the comments. You are going to be able to check this by your own. So this rosject, you have already a copy in your account, and you are going to have it forever, okay? So you can open it tomorrow, next week, next month, and keep working on this. So yeah, I'm going to leave this as homework to continue with the notebook and checking the different new features that have been introduced, and also some updates, changes since the Galactic release. Okay, so you have all the information here, all the commands, so that you can complete it by yourself. So yeah, I'm going to leave this as homework to all of you. Okay. I really recommend that you have a look, because all the stuff that we have here, it's super interesting, okay? You are going to find things super interesting here. Thanks, you were great again. Thank you, Arnoud. Thank you for being here today. And yeah, remember that if you want to get some of this knowledge in launch files, compilation, creation of nodes, etc., all these you can find them in the in our ROS2 Basics course. All right. So yeah, now let me do one more thing before I finish the open class. Very quickly, let me do it here very quickly. Just give me 10 seconds so that I can activate it here. This is a new feature, so I'm not so used to it. Okay, this is the second time I'm going to use it. All right, so I'm going to activate here a rate form that you can select. It works with starts in order to rate the open class if you liked it, if not. Okay, so let me activate it right now, and it should appear right now in the screen. Okay, so you can rate the open class if you liked it, if not, and this way we can have some feedback from you guys. Okay, I'm going to rate it in, I don't know, 3 stars, so that it's not too biased. Okay, and this way we can see if you are liking the open classes, and we can use this information to improve. We always want to keep raising the quality of everything that we do. So, so yeah, basically that's all. Thanks a lot for being here with me during this open class. Next open class, we are going to talk about navigation too. Okay, very interesting topics also. So stay tuned for next week, next Tuesday's open class, because it's going to be very interesting. Hope to see you all again there. And as always, take care and keep pushing your ROS learning. Bye bye.